Welcome to ZKast, everyone. I'm ZS Caravala from ZK Research, and I'm here at Arista's headquarters in Santa Clara, California. And we're going to be talking about networking for AI today, but specifically the age-old debate of Ethernet versus Infiniband. Now, to get things started, I actually completed a survey recently with the Cube Research. Bob Liberty and I partnered, and we asked the question, which customers prefer? And I'll just go through a couple of data points. And this data is hot off the presses, so it's pretty recent. We asked which technology customers would prefer. 59% actually said Ethernet, and 38% said Infiniband, with only a 3% don't know number. And if you've followed data sciences, generally that number is a little higher. So I think buyers have a good idea of what they want today, which I was a little surprised with. When I did a follow-up question asking why Ethernet or why Infiniband, on the why Ethernet side, it's what I was expecting. 46% said they can use it across the network. 44% said they have Ethernet skills in-house. 19% actually said they have no Infiniband skills. And so when you think about that, for about almost 20%, that's 1 out of 5 companies having no Infiniband skills in-house, that's a pretty barrier to climb. Now, on the other side, I asked for those who were pro Infiniband why they preferred that. 59% cited they believe it has better performance. And that believe number, I think, is an interesting one, because I think historically we've become accustomed to technologies like Fiber Channel and Infiniband having better performance within certain use cases, and so that's there. 42% said they prefer it because it's built into the compute stack. Another pretty large percent said because NVIDIA supports it, and to me that's kind of the same as built into the compute stack. But certainly from an ease of deployment perspective, buying it all at once, I guess does have some advantages, although we'll talk about the disadvantages now. I think, again, there's, I don't want to call it a holy war, but this debate has raged on ever since the whole concept of networking for AI has come about. And so to talk about that, I'm going to bring in a couple of gentlemen here from Arista Networks. And Arista, I believe has been a pioneer in networking and Ethernet really since your inception, although I guess the technology predates Arista. And we're going to start with Brendan Gibbs. You're the VP of AI Routing and Switching. Brendan, just a little bio on yourself.
So I've been here at Arista since the beginning of the year. Before that, I spent 20 years at Cisco and 5 years at Juniper. And so, as you say,
a lot of
networking, many years of networking. I'm super excited to be here.
And Martin Hull, VP and GM of Cloud and AI Platforms. Just a quick intro on yourself.
We just want to cover the last 13 years. I spent the last 13 years here at Arista Networks, but I did have a long career at Cisco and other companies before that, working in Ethernet networking.
Yeah. Now, so that first data point where 59% said that they prefer Ethernet to InfiniBand. Brendan, I'll start with you. Did that number surprise you? And if so, or even if not, why do you think Ethernet has such strong momentum today, specifically within the context of networking for AI?
It doesn't surprise me, because I think Ethernet is hands down winning the battle for hearts and minds. I think if you look at some of the earliest hyperscale leaders, they're building with Ethernet. By and large, the largest scaled environments that have the most experience are picking Ethernet. As you move into the enterprise, who are just starting to get their feet wet with AI, I think some of the metrics that you shared, where they love Ethernet, those that like Infiniband believe it has a better performance. I think this has a lot to do with people just not having done their own testing. And so it's just, they're thinking this, they're thinking that. I think as time progresses, we're going to see more and more devotees of Ethernet, because it just has so many characteristics that favor it. Broad vendor ecosystem, lowest pricing, essentially a proven ability to morph and change over time. I mean, Ethernet's been around for decades, and it's always risen to the challenge of the next use case. So AI is here. We're seeing Ethernet morph and evolve now. It's got the protocols. People are trying it, seeing it, and I think that percentage will grow.
Yeah, I think there was even a period of time where there was a debate of ATM versus Ethernet, right? Where ATM had superior performance in theory, but now Ethernet wide area networks far outperform some of those older technologies. Martin, did you have anything you wanted to add to that?
I think you also have to bear in mind with a survey like that, number of respondents, but is there a distribution curve on the size, right? The largest customers today are deploying Ethernet. And maybe the customers, as Brendan said, who are getting into an AI deployment might be using InfiniBand for initial trials, smaller deployments, and some of those might well continue on InfiniBand. But we do expect the volume, the scale, to favor Ethernet deployments.
Yeah, now let's go back. Let's go back a little bit in history here. Ethernet's been around a long time. It's tried and true and tested. But today's Ethernet isn't the same as the Ethernet of a decade ago, which wasn't the same as the Ethernet of 2 decades ago, right? So it's actually, even though the technology's been around a while, it's gone through many evolutionary steps. So can you talk about the evolution of Ethernet and how it's changed over the years?
Yeah, if you're going to try and go back 2 decades ago, we were just at the early stages of 10 gig Ethernet back in 2004 through 2006. And it's only really when we saw wide-scale deployment of 10 gig Ethernet that you saw that being deployed in some of what were the early HPC clusters. But we've moved a long way since then. 2004 to 2024, 20 years, we've gone from 10 gig to 40 gig to 100 gig to 400 gig, and we're actually now starting our early deployments of 800 gig Ethernet. So Ethernet as a speed has evolved very rapidly. And then if you pull back on that, Ethernet has continued to gain advantages and features and benefits. It was probably 15 years ago when the data center Ethernet enhancements were added. Where that was per priority flow control, enhanced queuing, end-to-end flow control. Those features were added because the legacy Ethernet couldn't handle the demanding requirements of state-of-the-art compute at that time. So 15 years ago, we put lots of enhancements in for data center Ethernet. At the same time, people started to implement fiber channel over Ethernet, and fiber channel has largely speaking gone by the wayside since then. So Ethernet has definitely evolved over the last 2 decades and 1 decade. And we're starting to see new enhancements come to Ethernet now. They're going to take it into the next decade and the one after that. Enhancements for AI networking.
Yeah, now, Brendan, you mentioned that the cloud providers have all coalesced around Ethernet for their AI initiatives. Why is it? When you talk to them, why have they preferred that? Is it speed, or is it some other factors?
Well, I think it's everything we've just said. It is got the broad vendor ecosystem, and it's got low pricing. It gives them the maximum flexibility. But kind of building on what Martin said in terms of the growth of the Ethernet technology, now it's adapted and adapting still to the needs of an AI workload. Come up with brand new protocols that have been around for a while, but people had to test for themselves, such as RDMA over Converged Ethernet, the version 2, or RoCE, as people like to call it colloquially. And I think the hyperscalers first tested that themselves, not taking anyone's words for it, and they found that at the very minimum, Ethernet could perform at par with InfiniBand, but I think what they found is there were ways to further optimize Ethernet for true lossless transport of that RoCE protocol. And so what they found was Ethernet outperformed InfiniBand. Ethernet was widely available. Ethernet had low power, broad availability, low cost. And there are now steps being taken to advance that even further with the Ultra Ethernet Consortium. So I think looking where it's come from and where it's going to, the broad availability and the most room to grow for lossless Ethernet transport, it becomes a clear winner amongst really everybody that's looked at it in depth.
So if I'm an Ethernet naysayer, I'm going to say, look, through all these evolutionary steps of Ethernet, there's been the cry that it's going to displace InfiniBand, yet InfiniBand still lives on. Why is that, and why do you think it's different now?
Well, I think your survey kind of speaks for itself. The people that are liking InfiniBand or sticking with InfiniBand are getting it as a bundled solution.
Well, Brendan, what's the risk of deploying a pre-configured cluster?
I mean, honestly, the reality is that lock-in is significant. InfiniBand is a single vendor solution offered by one vendor, and that can lead to higher pricing. It can lead to skill balkanization in a sense. It can lead to lack of ability to reuse technology from back-end to front-end, because if you're building a back-end technology with InfiniBand, that means InfiniBand switches plus a gateway from InfiniBand and Ethernet, and then Ethernet switches on the front end. you can't migrate that tech from the back end to the front end because of that lock-in, because of the non-transferability of the skills and the products. Ethernet changes all that equation completely. Ethernet generally is a wide open vendor ecosystem, generally lower prices because of a broader availability, and has the complete transferability of skills and technology. This is partly why our CEO, Jayshree, has been so vocal about what we call the AI Center, that an AI technology is not for back-end or front-end only. The benefit can be best taken advantage of when you think about it writ large, across back-end plus front-end together in that AI Center, and that's only feasible with an Ethernet, pan-Ethernet type of technology across the entire, sector.
Yeah, and I suppose too the other factor is when technologies become open and disaggregated like that, then you have the ability to upgrade parts of them, right? If otherwise, without it, I guess you'd wind up upgrading the entire cluster, even though you may not need to.
Exactly, and you're locked into the upgrade curves that the vendor deigns to provide. If it's fast, great. If it's slow, you're stuck.
Yeah, and where else have you seen momentum around Ethernet for AI? You talked about the web scale companies. I think that's been pretty notable. I think their adoption of it. What other types of companies have you seen been adopting Ethernet as part of their AI initiatives?
So you kind of break out this AI trend, pattern, explosion into a couple of areas. And clearly you've got the tier one hyperscalers, cloud specialty providers, and all of those are investing heavily in AI today. And the ones that are building out the largest scale networks are primarily going with Ethernet, right? And that's been shown. Then if you go to the dedicated startups that are implementing AI literally as their business model, you look at
AI
them,
is their business.
AI is their business. Their business is delivering an AI solution, not just a hosting type environment. For a lot of those, they go out and they look at the industry at large, and they want multi-sourcing for the GPUs, they want multi-sourcing for the network, they want multi-sourcing for every part of their network. Otherwise, they can't necessarily get the economics to work for that new business model. So those are the areas where we start to see a discussion about Infiniband versus Ethernet. And very often the economics play out in favor of Ethernet, and then it becomes a discussion about who's Ethernet. And clearly Arista is a market leader in high-speed networking. And as you look at networking for AI, the quality we have, the features, the product portfolio gets us a seat at that table. And if we continue to do our job successfully, then we have success in that area. But really, when you step back, it's that ecosystem, the broad ecosystem, the open technology. Many companies out there today, talking about startups, are coming out of stealth mode, and they're building their own accelerators, their own GPUs. The cloud specialty providers themselves, the hosting companies, are building their own accelerators. How many of them are developing a brand new technology solution that's dedicated to InfiniBand? I don't think it's very many.
No.
So Ethernet, I think, becomes that dominant technology. Will it fully displace InfiniBand? Absolutely not. Will it continue to gain market share? Yes.
Yeah. Well, certainly, I think even the people that are pro InfiniBand would tell you that the growth is capped, right? There's no new greenfield opportunities for it. So now you've been around in Ethernet a long time, as you mentioned, both of you have. You talk a little bit about what's on the horizon, and specifically, actually before that, let me back up a little bit. From an Arista perspective, I think when we think of Ethernet, we think of the hardware box, right? And from an Arista perspective, one of your value adds has always been what you're doing in software. So how has what you're doing in software made a difference with how you deliver Ethernet?
Like I said, I'm relatively new to the company, especially relative to Martin. I like to think of Arista as a software company, full stop. We do and build amazing hardware platforms, with I think one of the broadest portfolios in the industry. But I think what really sets us apart and why the hyperscalers and other customers are buying us and deploying us, more importantly, is the software quality and the software breadth. We have the ability to help customers go from consideration to trial to deployment and service productivity in the shortest amount of time, because the software quality is just bulletproof. Customers can rely upon the software. They don't have to make apologies. They're not woken up in the middle of the night. And when the whole measure of a successful AI transaction is low job completion time, an Arista network with the software quality and the high availability we offer literally offers the lowest job completion time, but because of availability. But on top of that, we have amazing performance of our platforms with the software that we write on top of the silicon to give that bulletproof, rock hard type of performance for AI workloads. And that's on top of, like I say, not even getting in all the details, the broadest hardware portfolio in the industry to give the maximum choice and optionality to our customers.
So even though Ethernet's been highly standardized and it's available from a number of manufacturers, customers should still do their homework and test one versus the other, because an Ethernet switch isn't always the same as another Ethernet switch.
I mean, the devil's in the details, so to speak, because there are standard protocols, RoC EV2, like we said. There's priority flow control, explicit congestion notification, PFC and ECN. Every vendor will talk about PFC and ECN, but there's an ability that Arista has taken advantage of to go a level deeper with more efficient load balancing characteristics, better quality of preservation of QoS parameters, and end-to-end congestion management for lossless transport. So just rattling off a couple standard protocols does not make one an AI leader. And that's what has differentiated Arista, where we've gone that next level for the performance and the quality and the efficiencies that other vendors can't match.
All right. Now, Martin, if we look ahead, what's in store for Ethernet and specifically for Arista?
Without giving out any secrets, for obvious reasons, back in June, we announced our first generation of the Etherlink portfolio that comprised fixed configuration platforms with up to 64 ports of 800 gig on them. We announced new line cards for the 7800 series that do 36 ports of 800 gig per blade. And we also introduced the new 7700 R4 distributed Etherlink system that's effectively a leaf spine physical, but behaves like a single contiguous system. So that was what we did in June. And if we look at those systems, they're high density 400 gig. We already know that the next generation of Ethernet networking will be 1.6 terabits. So over the next,
that, huh?
I know, it's terrifying. So over the next couple of years, it's reasonable to think that Ethernet will go from 400 gig to 800 gig to 1.6 terabit. And the use case that's driving that high rate of development is AI networking. The primary use case for 800 gig right now is AI. If I tried to convince the average enterprise customer they need 800 gig to the desktop, I'd probably struggle and fail. Yeah. But 800 gig in AI network is the starting point.
Yeah, gamers will want that, though.
Yeah.
Right. I remember when the first terabyte switch came out, right? That was pretty cool to be able to have a 1 terabyte of aggregate capacity.
Right.
Now you're talking at a port level.
Right.
Yeah, so that's pretty impressive. Now, while much of this talk track was around networking for AI. I think Arista has always also been doing a lot of innovation in the area of AI for networking. And Brendan, I wonder if you can talk about the relationship between the two.
I'm super excited about the prospect of AI for networking. I like to think about this as AI ops in the sense of AI for operations and I think this is honestly one of Arista's differentiators, is helping customers be more productive in an operational sense. What AI for networking essentially refers to is using the intelligence of either machine learning or generative AI to essentially glean insights from the network that otherwise would be very difficult to discern. Using AI technology to find that needle in the haystack to help operators figure out what the root cause of a problem might be, find optimization opportunities that might have been otherwise difficult for humans to pinpoint. And especially you think about this where networks get very large. It's very difficult for people, any one person or a team of people, to look at telemetry in real time across a global network with terabits of traffic and pinpoint that's the problem. This is going to be a problem. So it's not just today, it's also being predictive for challenges for the future. That's where AI in real time can take the data that gets ingested from the network and look for those needles in a haystack. And I think what Arista's technology, we've got something called AVA, or Autonomous Virtual Assistant. What that does is it leverages the deep telemetry our switches and routers are feeding into our network data lake, or NetDL, and sifting through all that data in NetDL and finding those insights. And then essentially it provides it to the operators. And we pair that with a conversational assistant that lets them query, how's my network doing today? So it's not just looking at this interface or looking at those bytes. It's asking, how's my network doing? How is the experience of these users doing? And it's synthesizing the inputs, giving outputs and outcomes with a significant operational advantage. So AI brings all that to the forefront, and we're offering that with our CloudVision software and our Ava chatbot assistant.
So is it fair to say for most organizations, if you're going to do networking for AI at scale, you really need to have AI for networking in place?
Yes, I absolutely think that's the case, because there's a thought of something being unsafe at any speed. Unsafe at any speed meaning have no insight to what the heck's going on. You could build a massive scale AI cluster with no telemetry data, and you could do very problematic things to your network because you just can't see. And that's actually one of the reasons we built, for example, our AI agent, which can run on hosts and on SmartNICs, to give that telemetry data, to give those insights on what's happening end-to-end throughout a network. So having an AI for networking capability for networking for AI is a match made in heaven. It's that peanut butter and chocolate type of combination to give insights to what's happening as you are optimizing the network. It becomes a virtuous cycle.
Yeah, and you really like peanut butter and chocolate.
I do.
Yeah,
I do love peanut butter and chocolate. So.
Yeah, that's good. And the last thing I wanted to ask you about was the Ultra Ethernet Consortium. You mentioned UEC. I'm not sure who wants to take this, but any updates from the consortium? What's going on with that? Where are we with that?
So last I checked, we're expecting the first draft of the UEC specs to come out fairly soon. The expectations are that that's going to put in specifications for effectively per packet load balancing, traffic spraying across networks. That will very much be a host configuration. So it comes into the NIC and the host as to how they're going to distribute traffic. The switches need to participate in that one. But we don't expect the impact of the UEC spec to require customers to go out there and buy all new network infrastructure. These should be, if anything, software upgrades to existing products, and those software upgrades should be applicable to products that we've been selling for many years now. So that's where we are with the UEC spec. We're still expecting the draft to come out this fall, shortly. And we're not expecting this to be a revolution. We're expecting this to be an evolution of the Ethernet networking.
Yeah, the thing I like about it is the breadth of companies that support it. Yeah. It's Arista as well as a number of your competitors. And typically, a lot of these consortiums haven't worked out in the past because I think everybody had their own agendas. It looks like from the companies I've talked to, everyone now has the same agenda: make the network better for AI. And that seems to have put to the side a lot of the typical competitiveness you see.
Yeah, the consortium's got silicon companies, systems companies, and more importantly, end customers.
Yeah.
So I think it's why you're seeing that collaboration to make sure we get to the outcome we're looking for: the end customers, the systems, and then the silicon companies.
Yeah. All right. Well, thanks. It was a great discussion. Is there anything else either one you want to add?
I think we're good.
I think we're good, yes. Yeah.
Well, certainly, AI is on the roadmap of every company I talk to. In fact, I think there will come a day where we stop talking about it as this futuristic technology, and it's just going to be built into everything we do. And to do that, we of course need to be able to build our own AI clusters, and the network's going to be a really important part of that. And so I was glad to have this discussion with both of you. All right, well, that wraps us up, this discussion of networking for AI and the debate of Ethernet versus InfiniBand. On behalf of Brendan Gibbs and Martin Hull from Arista Networks, I'm Zeus Caravallo from ZK Research, and thanks for watching. Please hit the subscribe button, and I'll see you next time on my next episode of ZKast.